All right, welcome back. So we just found the equation of this line, y equals 3/2 x minus 3. We identified what the slope was. It was given to us in the problem. We were given a second point, but unfortunately was not the y-intercept. So we had to use that x and y to plug into our original slope-intercept form, and we had to solve for b. Now when we wrote our final answer, we did not put in those numbers for x and y. We kept them as letters, because the equation of a line has y and x as letters, m and b as numbers. So we did not substitute those back in our final answer. So we got y equals 3/2 x minus 3. Let's look at another one. Example 5, write the linear function f with the values f of 0 equals -3 and f of 4 equals 3. Again, this is function notation. Really, these are just points, okay? The number inside the parentheses, those are just inputs. Do you remember what letter goes with inputs? Domain x, right? So these are x values. The -3 is an output. What letter goes with outputs? What letter goes with range? Yeah, it's going to be y. So these are y values. That means this function notation is actually just a really fancy way of writing 2 points. All we really have here is 0, -3 and 4, 3. So, nothing too fancy. We're actually going to attack this the same way. Notice this says write a linear function. Now those directions are a little bit different than we've been talking about before. Before we had to write the equation of a line. Linear function is going to be almost identical to y equals mx plus b. Again, I want you to think y equals mx plus b in your head. The only difference here with linear function from y equals mx plus b is instead of y, we're going to write f of x, or whatever letter that I told you in the problem. We're just going to replace the y with f of x. Remember, y and f of x are the same thing. So when I ask you for a function, I'm asking you for an f of x in the beginning. And we'll put that in at the very end. So we're basically just given 2 points. Just a fancy way, it's just different notation for writing 2 ordered pairs. So we've already done an example like this. First thing we found was the slope. M is slope. It's y2 minus y1 over x2 minus x1. So we need to label our points. Let's call this one x1, y1. Doesn't matter, you can choose which one you want to be the first point and which one you want to be the second point. It'll come out the same every time, I promise. y2 and this one is 3. So in parentheses, so that you don't lose your minus signs, put a 3. Then we have the minus sign from our formula. Then we have y1, which is -3. x2 in this example is 4, minus x1, which is 0. That double negative again becomes a plus. So 3 plus 3 over 4 minus 0, which is 4. And then we know 3 plus 3 is 6 over 4. 4 doesn't go in evenly to 6, but we can reduce that to 3/2. So we got 3/2 as our m. Now we need to find our b. We can check our points. There might be a shortcut. Are one of these 2 points the y-intercept, or do I need to plug them into our general formula as x and y? Let's take a look. Remember, the y-intercept is 0, b. So it might be easy, or we might have a little bit of work to do. Let's see. 0, b. Do you see a point that's 0, a number? Oh yeah, right here. Perfect. So it turns out our b is just that -3. We have our 2 pieces, so we can plug them into our equation. I'll start with our y equals mx plus b. Y equals m, we found out, is 3/2. Don't forget your x, and our b is -3. Now I did ask for a linear function, so the difference there is that I would like you to write it as f of x instead of y. F of x is equal to 3/2 x minus 3. Just going to write it in function notation. It's the same exact thing, it's just a different way to write it. Now you may have noticed something interesting with these 5 examples. Perhaps you did. They all had the same equation. I think that's super interesting. So whether I gave you two things in function notation, whether I gave the slope and the point, whether I gave 2 points, I could have written these things as a table, whether I gave you the graph, whether I gave you flat out the slope and the y-intercept, they were all exactly the same line. So you'll notice that no matter what information you're given, what you're really looking for is the M and the B. Those are the two pieces that are unique. And it really doesn't matter what information I give you at the beginning. All you need to do is identify those two pieces. And those two pieces will be hidden inside every single line with that formula. So whether I give you the slope and the y-intercept, or a graph, or 2 points, or the slope and a point, okay, those can all just be descriptions of a similar line. All of these lines have a slope component, a rate, and a y-intercept, a starting value component. Okay, these are all just different ways to represent or different pieces of information that I can give you about a line. And in the example today, those are all the same line. That won't always be the case. Most examples will be different lines. But I want you to see the fact that those are all just different ways to represent the same information. It turns out this is the line we solved for in every single one of those situations. I want you to kind of make that connection. Let's talk some real world examples. Let's talk when you're going to use this in real life. Clearly when you're filling a bathtub. So example 6 says, suppose you're filling a bathtub with water. After 2 hours, the tub has 6 gallons in it. After 5 hours, the tub has 12 gallons in it. Write the equation of the line that models this situation. So, again, I'm looking for keywords in the directions. Keywords I see here are write the equation of the line. And that should immediately trigger an equation in your head. It should immediately trigger y equals mx plus b. Slope, intercept, form. As soon as you see those directions, write the equation of the line. Bam. This is what we need. This gives us so much direction because now we know we're looking for the m and the b. That's all we need from this hoard of information. So I want to pull out two things. The most common situations are either I'm going to give you 2 points on the graph, 2 ordered pairs, 2 sets of information, or I'm going to give you the rate and the y-intercept, or a starting value. So in this case, do you think I gave you the slope and the y-intercept, or do you think I gave you 2 sets of points? Now a clue is that I gave you 2 sentences with information. So I gave you for 2 hours, the tub has 6 gallons. And then I gave you 5 hours, the tub has 12 gallons. So that leads me to believe I gave you 2 points. I gave you an input and an output, and another input and output. Okay, so let's write those as ordered pairs. Now remember, time is always the independent variable, meaning x. So if I give you a time, ever, it's always x. That means our first sentence after 2 hours, that's going to be an x value, 2. The tub has 6 gallons in it. 6 gallons is going to be our y value. Okay, so time, which is independent, is x. In this case, it's in hours. Gallons, or how full the tub is going to be our y value, our dependent variable. How full the tub is depends on what time it is, or how much time has gone by. Now the second sentence gives us after 5 hours, the tub has 12 gallons. So hours, again, is the independent variable, so 5 hours. And then the output would be 12 gallons in the tub. So I've actually just given you 2 points of information, and now, bam, we're right back to example, what was it, example 4? Nope, example 3. We're right back to example 3, same process. Now this one does give us a different line though. We need to find the m. M is y2 minus y1 over x2 minus x1. So let's label our points. x1, y1, x2, y2. Again, you can write those in any order, it doesn't matter. You will get the exact same thing. y2 here is 12, in parentheses, minus y1 is 6, over x2 is 5, minus x1 is 2. So I've substituted in my information in parentheses. 12 minus 6 is 6, and 5 minus 2 is 3. Turns out 3 does go into 6 evenly, and that is 2. So our slope for this line is 2. The y-intercept, let's see, was I given it initially 0, a number? Oh, rats, that one doesn't have an x that's 0. Ooh, and neither does that one. So here's the tricky part. Now I have to decide. I have this formula. I already know m, so I already know this piece of it. But there's 3 other unknowns. I have 2 points here. So I'm going to choose which point I want to use as my x and y. You get to pick whatever you want. Pick one, not both. I'm going to pick this first guy. It has smaller numbers. I kind of like it. If you want to, just as an exercise, you could pick the second one and see if you get the same answer as me. So I'm going to plug in 2 and 6 into my y and x. Remember, y goes with y, clearly, and x goes with x. So don't let the order of the point fool you and the order of the situation of the equation. So y from this point that I chose is 6. M, we already found out, is 2. In parentheses, x, oh, I didn't put my y in parentheses, terrible. Substituting. X is 2. And b, we don't know yet, plus b. So I'm just going to solve this guy. I'm going to write to the side since I'm out of paper here. 6 equals 4 plus b. I'd prefer you wrote this in your notes right underneath so that you continue your work down. I'd like to subtract 4 from both sides so I can get b all by itself. 6 minus 4 is 2. So my b equals 2. Now if you're following along and you did it with 5, 12, you'll get the exact same thing, which is awesome. Now we're ready. We have 2 for our m and 2 for our b. So y, remember we're back to letters for y and x, equals 2 for the slope, don't forget x, plus 2 for our b. So y equals 2x plus 2, and that will model how much water is in the tub. 2 is the y-intercept. That's our starting point. That means you started with 2 gallons in the tub when we started filling it at time 0. 2 means every hour we're filling 2 gallons. 2 gallons for every hour. So if I put in a 1 for x after 1 hour, there's going to be 4 gallons in the tub. After 2 hours, there's going to be 6. I'm adding 2 each time. So that's what that rate is telling you. It's a rate of how we're filling the tub. All right, awesome. Let's look at one more word problem. In this case, you're a taxi driver, so that's awesome. Turns out you charge $3.50 per mile that you drive with a customer. You already have $10 in your taxi because you are rolling in the dough. Write a linear model that represents the money you have, y, after driving x miles with customers. All right, the directions right here. Write a linear model. Write a linear model is totally the same as write the equation of the line. So our brains are immediately thinking y equals mx plus b. Helpful also that our variables we're supposed to use are y and x. That's lovely. Okay, so again, we're looking for the m and the b, but in this case, we were only giving 2 numbers. We were given that you charge $3.50 per mile and that you already have $10 in the taxi. So the fact that I only gave you 2 numbers is a clue that I probably gave you a rate and a starting value. Which part of this equation do you think is the rate? The rate is that $3.50 per mile. When you read that per, you're immediately thinking rate. So the rate is $3.50. $3.50 per 1 mile. Okay, that's going to be your slope. That's your m. The other value we were given was $10. $10 is your initial value. $10 is what you're starting with in the taxi. The starting value is your b. So we were actually already given everything we need in this situation. We were given that m equals $3.50, and we were given that b is $10. So we just need to write our equation. Copy y, m is $3.50. Copy x, don't leave him out. B is 10 plus 10. That means after 0 miles driven, I have $10. If I drive 1 mile with a customer, I'm adding $3.50. If I drive another mile, I'm adding another $3.50 to my total, and so on and so forth. That would be the equation of the line. I gave you a slope, a rate, and a starting value. All right. Awesome. I will see you in class. Hope you had a great weekend.